Hello students, welcome you all to the video lecture on Control Systems Engineering. Today we are going to find out the solution of state equation. So the given is x1 dot and x2 dot vector, which is given by the matrix A, that is 1 0 1 2 into x1 x2, and they have given that the initial condition x of 0 is given by 1 and 0. So the solution of state equation is given by x of t equal to e power at into x naught, which is nothing but e power at into x of 0, that is the initial condition, where e power at is a state transition matrix which is given by the formula pi of t, where pi of t is given by Laplace inverse, right, L inverse of pi of s, and pi of s is given by si minus a the whole inverse. Okay, so in the question they have given the matrix A as 1 0 1 2. So using that we can find out first what is si minus a, and then we can find out si minus a the whole inverse, and then we have to take inverse Laplace transformation and we can find out e power at, and using e power at and initial condition x of naught, we can find out the solution of state equation. Okay, so since the given matrix A, right, so A matrix is 1 0 1 2, which is 2 cross 2 matrix. I am considering the identity matrix as 2 cross 2 matrix. Okay, so Si minus A means I means identity matrix, so 1 0 1 0 1 I have taken. So S into I minus A. Okay, so the given A matrix we have taken. So multiply this value. So I have S into 1 as S, S into 0 0, S into 0 again 0, S into 1 S, minus A matrix 1 0 1 2. Okay. So now just subtract the values at the corresponding position. S minus 1 we have S minus 1, 0 minus 0 it is 0, 0 minus 1 it is minus 1, S minus 2 it is S minus 2. Okay, so this is nothing but Si minus A. Okay, so once we have obtained that, we have to find out Si minus A the whole inverse. Okay, so Si minus A the whole inverse we have to find out, which is nothing but adjoint of Si minus A divided by determinant of Si minus A. So this is the formula. Okay, and what is adjoint of Si minus A? It is nothing but cofactor of Si minus A the whole transpose. Okay, divided by determinant of Si minus A. So these are all the formulas. So in order to find out Si minus A the whole inverse, we have to find out first cofactor of Si minus A, and we have to take transpose of that particular matrix and divide that by determinant of Si minus A. Okay, so we have to find out the cofactor of Si minus A. So cofactor of Si minus A we have to find out. Okay, so we have to consider this matrix, right? So S minus 1 0 minus 1 S minus 2. Okay, in order to find out cofactor of this term, okay, we have to eliminate this particular row, this particular column. So remaining element is what? S minus 2. So that I have to write here. Okay, similarly we have to find out for other terms. Okay, so in order to find out this particular element, okay, cofactor of this particular element, we have to eliminate that particular column, that particular row. So what is the element here? Obtained element is S minus 1. Okay, that you can write here. So in order to obtain other diagonal elements, so in order to determine cofactor of this particular term, eliminate this particular column, this particular row. So whatever you have obtained here, now you have to write with changing the sign. Okay, just you have to introduce one minus sign and you have to write. So for these two diagonal elements, you have to additionally introduce one negative sign. Okay. So similarly again, in order to find out cofactor of this particular element, I have to eliminate this particular row, this particular column. So I have to write this term. While writing this term, additionally I have to introduce one negative sign. Okay. This is nothing but cofactor matrix of Si minus A. Okay. So not to obtain this particular element, just strike out this column, this row. Whatever you have obtained here, just write here. Similarly, you find out for other elements, and for this diagonal elements alone, you have to introduce in addition a extra minus sign. Okay. So solve this matrix. So S minus 2 is just Si minus S minus 2. Minus into minus is plus, so plus 1 here. Okay. Here minus 0, there is no change in that. Okay. Negative sign does not affect your 0, just 0 you can put. Okay. So now we have to obtain the transpose of this matrix. Okay, because we have formula cofactor of Si minus A, the whole transpose. Okay. So what is the transpose matrix? Cofactor of Si minus A, the whole transpose. Okay. Whole transpose means change your row, change your column. Okay. So this row will become now as column. So S minus 2 and 1 I have to write like this. This particular row I have to write as a column. So 0 S minus 1. Okay. So now this is your cofactor matrix. Okay. So once you have cofactor matrix, the transpose of the cofactor matrix. So once you have determined that, I can easily find out Si minus A, the whole inverse. Okay. So Si minus A, the whole inverse is cofactor of Si minus A, the whole transpose, divided by determinant of Si minus A. So let me determine determinant of Si minus A. Okay. So already I know that what is Si minus A. So determinant of Si minus A is nothing but this. Okay. So multiply this particular diagonal element, this particular diagonal element. So S minus 1 into S minus 2. Okay. Introduce one negative sign. 0 into minus 1 is minus 0. So anyway, this element is going to be eliminated. I just have S minus 1 into S minus 2. Okay. So that is my determinant. So once you have obtained that, let me find out Si minus A, the whole inverse. Okay. So I need to write this cofactor matrix. Okay. Cofactor matrix is S minus 2, 0, 1, S minus 1. S minus 2, 0, 1, S minus 1. This is transpose of cofactor matrix. The whole divided by determinant of this term. What is determinant of this term? S minus 1 into S minus 2. Okay. So now for each and every term, the denominator is this. Okay. So this I can write as S minus 2 divided by S minus 1 into S minus 2. Okay. Anyway, 0 divided by any term is 0. You can leave that as it is. 1 by S minus 1, S minus 2. S minus 1 divided by S minus 1, S minus 2. Okay. So once you have obtained that, S minus 2 get cancelled, S minus 1 get cancelled. Okay. So your Si minus A, the whole inverse is nothing but 1 by S minus 1, 0, 1 by S minus 1 into S minus 2, 1 by S minus 2. Okay. So this is now Si minus A, the whole inverse. So actually what is your formula? We need to find out what? E power at first. What is E power at? L inverse of Si minus A, the whole inverse. Okay. So I need to find out Laplace inverse of this term. Anyway, Laplace inverse of 1 by S minus 1 is nothing but e power t. Okay, but for this term I have to apply the partial fraction. Okay, for each and every term I have to apply the L inverse, right? So that is e power at is L inverse of Si minus a the whole inverse. Okay, for each and every term I have to apply Laplace inverse like this, right? Okay, so like this I have to apply for each and every term. So for this and all I know the formula directly. For this term alone I need to apply the partial fraction. So let me find out L inverse of that particular term first. So L inverse of 1 by s minus 1 s minus 2. Okay, we need to apply the partial fraction. A by s minus 1 plus b by s minus 2. So 1 is equal to, just cross multiply, substitute s equal to 2, substitute s equal to 1. Anyway, when I substitute s equal to 2, this term get cancelled, so only b will be available. Okay, so b equal to 1, substitute s equal to 1, 1 minus 2 is minus 1, a equal to minus 1. Okay, so L inverse of 1 by s minus 1 s minus 2 is nothing but minus 1 by s minus 1 plus 1 by s minus 2, which is nothing but so apply the Laplace inverse minus e power t plus e power 2t, right? Why? Because we know that Laplace inverse of 1 by s minus a is e power at. So using that formula I have obtained this, right? So now let me go to the problem. So I need to find out L inverse of this whole term, right? Okay, so now L inverse of this term is nothing but e power t. Anyway, this is 0. This is we have obtained now. This is the answer, minus e power t plus e power 2t, and for this it is e power 2t. Okay, so this is e power at. And what is solution of state equation? X of t equal to e power at into x of 0. So let me multiply this matrix with x of 0. What is x of 0? Given in the problem, it is 1 and 0. Okay, so this row with this column. So e power t into, okay, e power t into 1 is e power t. Okay, 0 into 0 is 0. This term into 1 is nothing but that particular term, and this term into 0 is nothing but a 0, so you can leave that. Okay, so this is your solution of state equation, which is nothing but your x of t. Okay, thank you. Thanks for watching.